All right, welcome students. Today we're going to study an introduction to functions. Now, if you look at the claw arcade game here on top, you would see that the claw will grab any item for you, right? Your input is your coin, your output is whatever object or no object that you get. Okay, so today we will identify functions from tables, graphs, and equations, and then we will determine real-world situation that describes a functional relationship. Okay, now, Mateo is playing a video game. You see this boy on top? He plays video game just like you, and the results are the following. This is the time spent, and this is the score. This is the input and that's the output. Okay, the left side input, the result is the output. There you go. 60 minutes, that's the results. 100 minutes, that's the result. And what else? That input could be named as the X. X is the input, Y is the output. You will learn new definitions. The word domain is the input, the range is the output. What else? The input is always independent. You just give on any value you want. But the result will be the output, of course, and you call it the dependent. The dependent depends on the input value that we put in. Now, is it true that when you play your video game, after a certain number of minutes, right, you will earn certain number of points? Okay. Now, that point, that output can be a function. Okay, how can it be a function? That's our next lesson. So let's review the definition. A function consists of a set of inputs called the domain. We already know that. And a set of outputs called the range. And this is the most important thing. And a rule by which each input determines exactly one output. So if this is my input, and that's my output. If I have a 5 here, the result, the output is just one number. If you follow any rule, it could be 29. All right? So this is a function. But if I have another input, okay, x and y, my input is 5 and the result is 29. But my input of 5 will also give me a 36. Whoa. One input 5 is just one single input, but it has two outputs. This is not a function. The first one is a function. In other words, only one y for every x. X cannot be repeated. Like that 5 cannot be repeated. We'll understand it fully with this real life situation. Tell me if this is a function or not. Remember, every input has exactly one output. A student and his her or their student number. Okay, think of your school. Does each student, like let's say the name of the kid is John, John has exactly one student number. Do you agree? Can John have two outputs, two student numbers? No. So this is a function. Function. Okay, now, can a person and the citizenship be a function? Let's say Jose. Can Jose be just a Mexican? No. People can nowadays can have dual citizen. So he could be Mexican American. Okay, so this is not a function. Not. Okay, the time in the taxi and the amount to be paid. For example, you rode a taxi for 15 minutes, and at the end, they computed how much you're going to pay. Let's say you're going to pay $50.35. Is it possible that for 15 minutes, you're going to pay two amounts? No, there's only one amount that you're going to give the driver. So that is a function. Every input has exactly one output. Now, the electricity used and the amount to be paid. For example, your electricity bill. So let's say you spent N kilowatt hours. Kilowatt hours, and you'll have to pay a certain amount, $30. All right? Is it possible that you're gonna pay two separate amounts for One input? No. So this is what? A function again. Function. Okay, age of the student and the height of the student. Are all 12-year-old kids would have a height of 5 feet 2 inches? No. I saw another 12-year-old kid who is 6 feet. So one single input has two outputs, not a function. Not a function. Okay, a teacher and a subject taught. Hmm. Think of one teacher, let's say Raymond. Raymond teaches math. Is it only one output? No, there's Raymond also teaches PE. Guess what? He also teaches science. All right, one input has three different outputs, therefore, not a function. Not a function. Okay. Now let's look back again at this kid playing a video game. Mateo, which of the tables would show a function? 10 minutes, score. Okay, can you see the score? One single input, but one output only. This looks okay, right? How about this? In 10 minutes for 10, 10 minutes to 30. Can I repeat my X? No, I cannot repeat that because that's a single 10. A single 10 cannot produce two different outputs, 1 and 2. So you're not a function. How about 10 has this result? This has a result. 60 has a result. 10 has a result. Okay? Each input has only one. But one kid said RAM. How come we repeated 410? Can the Y repeat itself? Yes, the Y can repeat itself as long as one input has exactly one output. So what can we say? Which of the following are functions? The functions are this one, functions, not a function. This is a function. Okay, so we've been studying function written as a table. This is a table. Okay, but remember, if you get the x and y, okay, this one becomes a what? This one. See that? You're just writing them down as ordered, ordered pair. Okay. What else? I can also write them this way, like a set on the left and a set on the right. You call this a mapping diagram. Mapping diagram. Diagram. And look at the coordinates. It matches the correct function, right? It's the same thing, but they look different. There's a third way. This is a graph. Okay, graph. Because you see the x-axis here, the y-axis over there. But guess what? You can also see functions written as an equation. All right, so how many ways? One, two, three, four, 5 ways that your function could represent itself. So let's check out our tables. How will I know if a table is a function? Again, check out your x input going to your y output. Okay, every input, 2 has an output, 3 has an output, 4 has an output, 5 has an output, 6 has an output. That's a function. One has an output, but that the same one also has a 5. Whoa, can one have a 5 and one also have a 2? That cannot happen. This makes it wrong. So this is not a function. Okay? If you just see two repetitions of the x-axis, it is not a function anymore. Okay, now, in mapping diagram, let's check the first one. Each one has a 3, one has a 4, 3 has a 5. Okay, we're good. Function. This has one output, one output. -2 has an output. It just happens to be 4, but that's one output. So that's still a function. All right? Function, function. I repeat, the y value can repeat itself. But here, the next part, 1 has a 1, okay? But 9 has a 3. one output, and the same 9 has another output of -3. That cannot happen. So not a function, okay? No repetition of the input. Same thing about here, the next one, okay? 3 has a 5 and 3 has a 6, okay? Wait, yeah, because it's the same 3. So not a function. Now, an ordered pair could also be a function or not. Look at the input and output. 3 has a 1, negative has a 1, positive 1 has a 1, 3 has a -1. See, repetition of the 3, not allowed. A single 3 should only have one output. Okay, so not a function. So this one you're okay, this one you're okay. All right. No repetition on the x. No repetition on the x. See that? No repetition on the x. No repetition on the x. The first number is the x. Okay? So only this, the first one, is not a function. Okay, a graph. All right. So if you're looking at the graph, it's hard to write down all the x and y coordinates. So we're going to use a shortcut which mathematicians use. You call it the BLT. Okay? Bacon, lettuce, and tomatoes? No, it's called the vertical line test. What is a vertical line? Think of this as the vertical line. All right, that's a vertical line, and it goes up and down, of course. And guess what? That vertical line will travel from left to right, okay, or right to left. It will travel from left to right, and that vertical line wants to touch your graph only once. Okay, look at the circle here. Look at the circle here. We're looking at this. This vertical line would actually started moving from where? This vertical line started moving from the left side. Okay, here we're okay. It touches once. But here it touches twice. It touches twice. Until there, it touches twice. If it touches twice, meaning there is one x, but touching 2 times. That's not allowed, remember? So this is not a function. But here, wherever I put my vertical line, it only touches the graph once. Can you see that? All right. Wherever you put it, it only touches once. That means for every x, there's exactly one y only. All right. So this is a function. So left to right or right to left. Okay. So let's look at the first example. Here, we're good. It will touch once, but here it will touch twice already. Not a function. I'll just put an X. Here, it will only touch once wherever you go. All right. Touch the graph once. So you're a function. You will be touched once only, but here, as you move on, wherever it go, okay, it touches twice already. Not a function. The next one, try the next one on your own first. Pause and then tell me, I'll tell you if you're right or wrong. Okay, so left to right, this is a function. This is not a function. This is a function. This is a function. Not a function. Not a function. Okay, got it? The line will move from left to right. It should only touch your graph once for every vertical line that you make. Now, if it's an equation, before I give you the rule, look at the left side and the right side. These are all functions. These are not functions. What can you say about the functions? How would an equation look like? Check it out. Yes, what is common among this? What is common? Okay, think first before I give you the answer. Here, y is isolated. Y is alone. Y is equal to a certain term or a number. Here, you can move it away so that y could be alone. Look, I put plus 5x here. I put plus 5x there. All right. So this becomes what? Y is equal to, that cancels out, 5x plus 1. See, Here again, y is alone. Here, y is alone followed by a term. Y is equal to followed by a term. So take note, an equation is a function if you would see y is equal to something. All right, how about this? The next one is not a function. Look at the next examples. Why are these not a function? Okay, but because x is equal to, because of that. We cannot, it's y that we need, not the x. What else? I see a y here, and I see an equal. But guess what? The y is squared. You cannot do that. What else? Here, the y is squared. You cannot do that. Anything where x is alone, and whenever you see y squared, that makes it not a function. Okay, so remember that. Oh, by the way, whenever you have an equation, for example, y is equal to x minus 5. Now, in algebra, they will rename now y because y is a function. Y will have a new notation. You will write this as what? Oh, we have it already here. That's now called the function of x, but it also means y. Don't be scared. The function of x means the value of y. Which answer explains whether the table of values represents a function? Okay, let's see. -4 has one value, -2 has one value, 0 has one value, -1 has one value, -6 has one value. So it is a function. Yes, yes. So we cannot answer that, but which would be a good explanation. The values represent a function because each x value is paired with only one y value. But here it's the opposite. Each y value is represented by only one x value. No, it's one x. For each x, there's only one y. So this is our correct answer. Now this problem is good because function is disguised in four different ways, and I want to know which is the real function. Okay, so let's start with this. Every input has exactly one output. 1 has a 2, 7 has a 6, 3 has a 2, 1 has a 0, 5 has a 6. Guess what? Same number, one single input of 1 has an output of 2 or 0. That is not allowed. I only need 1. Okay, as a table, 0 has an output of, oh my God, same 0 has four outputs. That's not allowed, not a function. All right, so an equation, look at this, x is equal to, remember to make it a function, it should start with y is equal to, so not a function. Now, the last one, obviously, this should be the correct answer, but how will I check that? I use my vertical line test. My vertical line is at 3, -3, it doesn't touch. If my vertical line is at -2, it will touch there. If my vertical line is 1, it will touch once. If my vertical line is at 1, it will touch over there. See that? The vertical line test will only touch one point of the graph. So the last one is the function. For the next one, which figure correctly demonstrates using a straight line to determine the graph equation is not a function? We know it's not a function, right? But which is the correct use of the vertical line test? Okay, left to right. This seems okay, right? I see the vertical line. Okay, this is a horizontal line. We didn't use the horizontal line test. This is another horizontal line test. We never use that. Here on the third one, I see a vertical line. It could possibly be that. Okay, but remember, a vertical line should only touch once. Here it touched once, but when it moves, it should touch two. So this doesn't prove it is a function. Okay, so but this will prove that it is not a function. See, because of these 2 points touching. So the correct answer is this one. Now this is the last problem. A fun zone, okay, an arcade, okay, where you play video games, they have four party packages. This is 1, 2, 3, and 4. Okay, what else? The prices for each package are $50 more on weekends than they are on weekdays, right? That's why it's $50 more, right? Can you see $50 more on weekends than on weekdays? See the difference of $50 as shown in the table there. Okay. In which statement best describes the relation, okay, package number and the price? One input and one output. Is that correct? Now, it is a function because there is a price given for every package. Okay. It is a function. Weekend package are always 50 more than the weekday package. Oh, we know that's true. It is not a function because each package number has two different prices. Is that true? One could be the input of one could be 150, and the input of one could be 110. That makes sense. It is not a function because there are two different packages available for 180. Okay, remember the y value can repeat itself. It doesn't matter. But here, this is the number that cannot repeat itself. So it is not a function, and the third statement explains why. So that's it. So now you know what functions are. So remember, guys, results is equal to action plus motivation. Okay, good luck.